Okay, so the main box containing most of the electronics for control system contains quite a lot of components. First we have our main power cable with BAO jack. It's 8+1 jack. One is for the solenoid and the others are for DC motors and voltage. So this jack enters the box, goes through current sensor over here, then goes to our main power switch relay. So this relay is controlled by the user through one of the connectors. So the second relay over here is used to power up or switch off the solenoid here. So next, the main controlling of the wheelchair is made by this Arduino 2560 here. So for controlling DC motors we have two H bridges, two drivers for every motor. So these wires go back to our main BAO plug. So, and we have here our second Arduino 2560 which gets the data from all ultrasonic sensors through these wires and is connected to USB with this jack. The control box is quite compact when all components are put together, so it is easily set into the wheelchair just by putting it inside. And connecting the BAO connector. After installing the box containing the control system, we have to plug in these connectors into the batteries to power up the system. Each wheel of the wheelchair has an encoder which is implemented with a plastic disc containing 3 lines of magnets. The total number of magnets is 360. So the magnets are read by 3 Hall sensors aligned with the lines of magnets, and these schematics reading the Hall sensors is then connected to the control box with this wire. The wire going from the encoders has an 8-pin connector which is plugged into the control box and fixed, and the second wire is from the second wheel, and the second encoder is also plugged in. The next step of putting together the speech-controlled wheelchair is mounting the holder plate for the Intel mini computer. This holder plate also has a voltage regulator from 24 to 19 volts to power up the computer. So this plate is mounted here over the batteries and fixed with 2 bolts. After mounting the holder plate for the computer, we need to plug in the input wire which goes to voltage regulator into the 24 volt plug, And here we have the 19 volts output for the mini computer. The next step is mounting the Intel NUTS mini PC. So we just take it out of the box and put it here into the holder, fix it, and plug in the 19 volts from the regulator. The next step is connecting the power system to the mini computer. We have here two plugs for two Arduinos. First we connect our main Arduino 2560 and plug it into the mini computer. Next we use this wire to connect our second Arduino, also using USB connection. Next step is connecting the wheelchair control system to the mini PC. So here we have the connector for second Arduino 2560, which gets the data from ultrasonic sensors, and we connect it to the mini PC using USB connection. Second, we connect the first Arduino, which controls the wheels, with USB wire to the mini PC. The wheelchair consists of two parts. One that we already described is the power part, that contains two DC motors, batteries, control system, mini computer, and several ultrasonic sensors here. The second part is the chair itself for the patient, which also contains the power switch, LED matrix to show the commands which are now active, and a set of sensors, including ultrasonic sensors here and here, two infrared sensors in front, and also a LiDAR here.
We can see the LiDAR rotating now.
The next step is putting the wheelchair together. This is done by putting these holders in, and next plugging them in on each side. After putting together two pieces of the wheelchair, we can use the handbrake here to drive the wheelchair around. After putting together two parts of the wheelchair, we have to connect all of our sensors and power switches. So on the bottom part we connect the front ultrasonic sensors here and here, as well as two infrared sensors. After connecting the lower connectors for the sensors, we have to connect three upper ones. One is for a power switch, the second one is for LED matrix, and the third one is for emergency sound sensor. The next step is connecting the LiDAR to the mini PC. Through this wire we get the data from laser distance sensor, and here we have OR to USB bridge to get the data on the mini PC. Except the sensors that we've already described that we have on the wheelchair, we also have this sensor to get the pulse and oxygen saturation of the patient. This board is produced by Norin company, so to get it working we have to plug in the 9-volt battery in and plug this USB into the mini PC on the wheelchair. The box containing the sensor reading the pulse data from the patient is fixed under the plate. The sensor is given to the patient and the data is transferred with a USB connection and the bridge is connected to the mini PC.
We start the system by pressing the on button on the nuts.
After starting up the Intel mini computer, we can go to its IP address and port to get access to Cloud9 interface. Using this interface we can change the code on the wheelchair in real time and also run it. After starting the Intel mini PC and accessing the Cloud9, we could issue the commands to start the control algorithm. And after this we could go to the wheelchair's IP address to access the interface for speech control. To be able to control the wheelchair without any smart devices which have a microphone, we could go to Intune's desktop with TeamViewer, open Google Chrome and type in the IP address of the wheelchair to access the speech control interface and start talking the commands.
Go right. Go. Go left. Go. Stop.